Hi, everyone who's listening live or watching the recording. We welcome you to our first Inventor Gathering of 2026, presented by Public Invention, a 501(c)(3) nonprofit funded by donations of others with the mission of inventing in the public for the public. My name is Megan Cadena, and I'm a biomedical engineer working in the medical device industry. I specifically work in R&D for acute renal devices. I am also the outreach coordinator for Public Invention, and I will be co-speaking tonight with a dear friend and fellow researcher with Public Invention, Nagham Kheir. Take it away, Nagham.
Hi everyone, this is Nagham. I'll be talking to you later about Krake and ADaM. Hope you enjoy it.
Perfect. We are excited to be presenting about alarm management in medical devices tonight, and hope you're able to take something from this presentation. So what is alarm management? Alarm management is a way an organization designs, uses, and continuously improves alarms. So they only alert individuals or intended users when something needs action, and the alert is clear, prioritized, and helpful. So an alarm can be a sound, a pop-up, some type of notification almost for a very critical scenario. In alarm management, an alarm should mean at least four things. This is that one, something abnormal is happening. As well, a person must take action, that there's a specific or limit to the time to act, as well as the alarm should tell you what to do or where to look. If no action is needed, it's usually considered an event or a message, not typically an alarm. So it's important that we break down some concepts that come with alarms and alarm management systems, just so everyone has a general basis of understanding. So there are alarm types, alarm classes, and alarm priorities. I like to start bottom up. So the alarm types you typically see, these are like what kind of a thing it is. Think of it as like what it's going to kind of address. And so I see typically four of these in the field that I work in. So typically there's process alarms, system or instrument alarms, diagnostic alarms, as well as safety alarms. So process alarms, think of these as a variable that goes outside a given threshold. So this could be those permutations of priority that are like high, low, or medium when it comes to rate changes or deviations, so like pressure, flow, stuff of that nature. Then you have system or instrument alarms, which are more controller system issues that arise. This could be like PLC or DCS faults. This could be a communication loss. This could be a watchdog, or this could be a time synchronization alarm. As well, there are diagnostic alarms, which are more of a device self-test that failed. This indicates sensor failure, or maybe a battery's low, or calibration's due. These system component-based alarms are more diagnostic than they are system or instrumental separately. Then you have, of course, safety alarms. These are tied more to the safety of the instrumental function of the device. I like to think of these often as very strict, very constrained, because they're based off of handling and usage, which takes into consideration risk mitigation and patient harm. So now that we kind of understand the different alarm types and categories and how they get defined, actually, let me go back. There are different priorities to some alarms. And that's one thing I definitely need to cover in this presentation, is that alarm priority is very crucial because it's based off of two factors, risk and urgency. So let's say a certain scenario happens where there's a high, medium, or low priority alarm. How do you categorize what circumstances fall into low versus high priority? I would say it's really just the summation of two things, the severe consequence that will form and that it's alarming you about, as well as the duration to act. If you have a very like major consequence to the patient, then you're typically going to have a shorter time to act. Whereas when it's less severe of a consequence, you typically have a longer period of duration or action to respond or mitigate the alarm. And of course, there are permutations that fall somewhere in between those two boundary cases. And this is important because this tells you how to classify different alarms than different classes. And even within those classes, how you prioritize risk or the priority of things in your system, your specific design system. So now that we understand all of that, to the basic entirety that we have presented up to this point. What are issues with alarm management? What are things that can go wrong or things that haven't yet been optimized in this field? And typically I see it as one is alarm fatigue, which I don't know how many of you are very comfortable with this vernacular, but essentially it's the desensitization of frequent alarms or non-critical alarms. And this happens because critical care providers or practitioners like nurses, doctors, PAs, they can see thousands of alarms per day in critical care settings, whether from one machine or multiple machines. And the bombardment of these alarms can lead to kind of a lack of sensitivity to them, as well as maybe a panic, a poor response, or just not the most critical response for the patient outcome, better patient outcome. And so they tried, you can see throughout peer-reviewed research, but realistically, they try to mitigate this alarm fatigue by doing better alarm allocation and preventing alarm misuses, as well as a reduction of total alarms provided in that given alarm management system. So it's really important to understand that you don't want to bombard users with an excess of alarms if you can make it more clean, efficient, and reduced because of the risk of alarm fatigue. As well, you can have inconsistencies in alarm limits and default settings across different devices and units. And I really like this graphic that Nagham found because it really isolates the different categories of alarm management issues you actually see. So like nuance alarms or frequently occurring alarms, these can contribute to alarm fatigue, as well as alarms not requiring a response at all. Why are they categorized as an alarm instead of a message or an event? This can be alarm misuse. As well, alarms that flood during process upsets. So in the most severe times or when critical alarms hit, if other warnings or maybe, let's say reminders appear at the same time, that's unnecessary bombardment instead of higher prioritization. And I would recommend an optimization to that alarm management system. Even uncontrolled alarm suppression. So you want to give them options to mitigate, mute, or silence and dismiss certain alarms that aren't as crucial. So if critical alarms do arise, they can respond promptly to those and even prioritize those if they, let's say, occur at the same time. So one thing we do want to highlight here is what is the difference between an alarm, a general purpose alarm, an annunciator versus an alarm management system? Well, general purpose alarms are simple warning systems to alert users about a critical condition that requires attention. Whereas an alarm management system manages the human attention to complex, overlapping, or even ambiguous alarms that can occur in intensive care units and other clinical settings. And this is important because it's the prioritization and the reporting in different state systems that this system is managing. Because one patient treatment may be completely different than how the same patient treatment goes on another patient, or even a different modality. As someone who works on acute renal devices, I see that there are multiple modalities for therapy to be delivered on the same machine. And of course, you're going to see different alarms with every therapy run, but even for the same modality, different responses like to hive pressures can lead to other consecutive alarms. And so that's why the beauty of alarm management systems is that it can create different state systems to respond in prioritization to initial stimulus that lead to a cascade of different events. So taking a step back from all the technical jargon and general understanding of the value of these systems, I wanted to give a little bit of, I guess, like an overview of like what the market really looks like for clinical alarm management from 2025 moving to 2030. And I think this is crucial because some people might say, sure, I understand the value of alarm management systems in critical care settings or medical devices. Well, why should I care about this if I don't work in these domains or fully understand and grasp the weight of these devices? Well, because the market is only going to grow and it will impact you as a user, it will impact you as a family friend to a patient, or even further as a future provider or someone who engineers products to go in tandem with these devices. So just looking at the market size right now in USD or American dollars, the market's actually around $3 billion for medical devices that have alarm management systems. And it's expected to grow to about 11 billion by 2030. And if you're really someone into the financial market in like scheme landscape or financial schemes and the market landscape, then you might be very comfortable with compound annual growth rates. If so, this device market is actually looking at a almost 30% rate of growth. And you might be wondering, so why? Why is it booming? Why is there value in this, I guess, sector of medical devices? And honestly, it's actually really surprising. It's because of alarm fatigue. The current issue with bombardment of alarms to like patient-centered environments, critical care environments, and the intended users, providers, and nurses show that there's a higher demand for more optimized systems and demand for even different systems altogether, as well as there's obviously a growing need for the cost containment attribute of it, and even the unfortunate consequence of things such as the pandemic have led to a prolonged hospital stay for many patients, as well as the increase of technological advancements in medicine. But unfortunately, with the rising prevalence of various chronic diseases and morbidities in combination in one patient or multiple, leading to their, let's say, entry into some critical care settings, unfortunately. And so these higher demands, as well as the aging population, are really leading to a bigger market demand for products like this. And it will impact people at various scales, not just engineers and not just healthcare providers. So with all the seriousness out of the way, I think it's important to also consider the fun stuff, the creative stuff, and the other attributes that go into design of alarm management systems in medical devices, which would be usability. So usability goes into the intentions of the design for the intended user. And typically this is done outside of R&D, which is my domain, and more in human factors. So I can't go into the details of a formative or summative study and how they aggregate data to better understand the intended user and how they use machines like dialysis or other acute renal devices or other medical devices altogether with alarm management systems. But what I can do is kind of dig into these concepts that we feel are very valuable and insightful to understand why you have to consider the user thoroughly in your engineering design. So some that are most interesting to me would be the alarm must support human cognition, not overload it. And you see this with really common factors like prioritization is very crucial. It goes into literally how you organize your schema for ranking alarms and prioritizing them, as well as it needs to be actionable. It needs to have distinctiveness. It needs to have awareness spread, as well as context awareness to help spread the critical attributes that are necessary for proper functioning and reduce patient harm or risk. As well, it needs to have training. I think we've seen so many nurses who know how to work in the field, who have much experience working on different devices. But imagine you're tired, you're probably hungry, you've seen so many code blues in the night, code blues throughout the night that you were forced to kind of go into dissociation or like I would say resting state. And so when bombardments of alarms and different circumstances that are very critical happen, it's sometimes really difficult as the user to understand how to mitigate specific issues on various machines all in the same setting. Critical care settings have, let's say, infusion pumps, ECMO machines, ventilators, as well as dialysis machines. And those are just four. Typically, they're surrounding the beds and very overwhelming with high decibel sounds, multiple alarm LEDs, and different cues. So imagine the stress that can inflict on an intended user. With this in mind, you have to think about what a human can really process in these settings, and also what mental loads they can bear. And this is important for the design because it goes into risk mitigation. When we go into regulatory standards, you'll kind of understand a little bit more, as well as kind of the usability, of course, how well does it function in this clinical environment? And even how well are people trained to use this? Does it make sense? Is it effective at reducing patient risk? And this is important because we've seen trained nurses go and use devices incorrectly, simply because it wasn't intuitive when to make a change, even with, like, let's say, images in GUIs or user interfaces, or even with manuals and instructions, because sometimes users don't have the time to process these cues while the emergency is happening. So it's really important we make them very simple, very obvious and effective. So those are kind of the notes I wanted to hit with this slide. Is there anything, Naga, maybe that you want to add here?
Thank you, Megan. as I was listening, I was thinking, I'm gonna go off script at the beginning of my slides because I wanna go back to these and say, um, this is the symptom of things not being documented. So, um, what we're going to talk about in the next slides will be first documenting what the most experienced operator would do when an alarm goes off. So, when nurses are in these situations and their mind is flooded with too many things, in addition to the alarms, they have something to reference to and rely on. So they can know the correct action that they can take in the right moment. Back to you, Megan.
Thank you. No, I love that you added that note because you would be surprised how much documentation can really save lives. I think we'll hit that more with the standards and regulatory guidances. So let's keep moving, but I really love the notes that you brought up there. So, okay, what can open source offer in this domain? We feel that open source has always offered creativity, collaborative environments, and transparency in any domain. But for medical device alarm management systems, we think that it can only benefit in helping with the standards, open standards, and safety to help with patient risk mitigation and patient safety, as well as the interfaces or algorithms and integration layers that are the foundation of all systems. This is because why should you be reinventing the wheel? This is similar to how many for-profit firms use foundational components made and created and honestly brought to life in open source communities for-profit designs later. So it's crucial that sometimes you can really take value from open source designs to build for-profit functional designs that get regulated, patent controlled, and even help benefit and maintained for the sake of a patient need. So I would argue this domain has so much opportunities and breadth to support the existing medical device industry. Today, we're going to look at two case studies or existing projects that they actually were designed here at Public Invention, the Krake and the ADaM. So I'll hand it off to Nagham to take it from here.
Thank you, Megan. That was wonderful. Next slide, please. I will start by introducing a quote from a book by Holyfield and Habibi. It states, "The control system must become self-correcting and self-optimizing, which means the system must adapt heuristically to reduce, not increase, the need for operator intervention." What do we mean by that? Before we go any deeper into Krake or ADaM, I'm going to introduce us to certain regulatory standards that shaped our design. Next slide, please. First, please note that references to medical devices standards in this presentation are provided for informational and design planning purposes only. Krake ADaM has not been evaluated against these standards, and no claim of compliance is made. Any future use of Krake as a medical device would require a formal regulatory strategy, appropriate resources, and the successful completion of all application, verification, and validation activities, testing, and regulatory review approvals. Outcomes are not guaranteed and remain subject to testing results and regulatory determinations. I'm sorry, I just needed to say this disclaimer very front. So now that been said, let's move to next slide. I'll start by briefly framing the standards landscape, and then I'll narrow us into the medical use case. ISA 18.2 is the process industry standard for alarm management. We'll discuss the alarm management lifecycle defined by ISA 18.2 next. But for now, we're gonna mention other standards. IEC 62682 is the international counterpart built directly from that same body of work. When alarms are part of safety instrumented functions, IEC 61511 governs safety instrumented systems in the process sector. and it is aligned with the functional safety principles of IEC 61508. Now, shifting to medical devices. IEC 6061-1-8 defines the requirements for alarm systems in medical electrical equipment and medical electrical systems. What this standard gives you are requirements and tests for alarm behavior, including alarm priorities and categories, which Megan mentioned in the previous slides. I think it was like second or third slide when she was talking about priorities, classes, and types. Consistent audible and visual signals are also required and tested in this standard. Alarm controls and states, and marking and instructions for use expectations. Also, the documentation for these is what's basically covered by these standards, and it's crucial, I'd say. All of this is supported by risk management under ISO 14971, defines the this ISO standard defines the full life cycle process. I'm gonna jump to regulators also, like human factors and usability evidence, one's guided by FDA human factors guidance. I think I skipped something here. Did I mention the risk estimation and the hazard identification? I don't think I did. So in the ISO 14971, we have hazard identification, risk estimation and evaluation, and risk control, and production and post-production monitoring. Okay, now I've said that.
May I chime in here?
Only if you'd like to, but let me go over the regulators for like guided by the FDA human factors guidance and the IEC 62366-1 ecosystems. The expectations is to prove that the user interface, including alarm interaction, minimizes use-related risks and that intended users can operate the system safely and effectively. The rotary encoder used, for example, in Krake. I'm gonna try to stick to just mentioning the standards, and then I'll jump into Krake and ADaM, as I mentioned before. There's also a clinical operations layer driven by accreditation bodies, most notably the Joint Commission. The Joint Commission has a clinical alarm safety goal, NPSJ 060101, that expects hospital to prioritize alarm safety, identity, key alarm signals, and define policies for alarm settings, disabling, authority, and response. Starting January 1st, 2026, the Joint Commission is introducing National Performance Goals, or NPGS, which will replace the formal NPSJ chapter for hospital and critical access hospitals. Why does this matter to us as device and system builders? Hospitals increasingly expect vendors to provide alarms-related documentation, including recommended defaults, alarm limits philosophy, which we're going to talk about next, training guidance, alarm audibility expectations, integration guidance, and support for alarm fatigue mitigation. So, okay, before bringing this back to Krake and ADaM, Megan, would you like to add anything here?
Yes, thank you. So as I was trying to consider how to take this from the angle of medical devices that I have exposure to, I wanted to consider the overview that I typically see in high-level documentation down to lower. And so first, we mostly see the critical standard as IEC 6060118, which is the alarm system requirements. This is important because it defines how medical device alarm systems kind of need to behave, not kind of must behave. So think of it as the context of alarm priority levels, characteristics, of the alarm, like audibility or visual signaling, and what that should look like, consistency, recognizability across the devices, and even so, the requirements should aim to target alarm fatigue. And some examples of, I guess, what these standards govern for, like, let's say, dialysis machines. I've seen it go into how you report critical alarms for blood pressure, let's say air embolisms in the blood, temperature regulations, conductivity issues in the set, or even flow interruptions. These are all important. And if these were to be missed, severe patient harm would erupt. So these technically, the alarms governing these kind of requirements and these risk factors would fall into this IEC 6060118. Then you can take a little further and you can go into the risk management document that Nagham mentioned, which was the ISO 14971. This is every field of regulation and quality standards will always consider some type of risk mitigation. And so this is the one I've seen with medical devices, which is it requires that every alarm is linked to some specific hazard or defined hazard. It also has, justified priority or justification for the priority level given to the alarm, as well as it needs to show demonstrated effectiveness to reduce this risk. This is the context I've seen this documentation kind of use or take into regard. So that's where you would go for kind of like what part of the DHF would apply to risk mitigation, go to ISO 14971. But then if we dig a little deeper in terms of dialysis systems, this ensures specifically just life-threatening conditions trigger high priority alarms, while nuanced ones are minimized. So then you have to think a little bit deeper. Okay, so then what would be other requirement standards that you take into consideration? Well, the third would be usability. And this goes back to the human factor slide we've been talking about, which you see in IEC 62366. This one's not on the slide, but actually it's really essential because it goes into details about why alarm systems should align with human factor expectations, making sure the alarms are perceivable in different clinical environments, as well as can a user correctly interpret and respond under stress. These are crucial to system validation. If you don't design something for the right user, then you might have verified it to correct standards, but it doesn't meet the intended need and it won't address the issues in the field. So this can look like multiple things, but essentially it's important that in, let's say, an ICU or critical care setting, that they're able to manage multiple machines simultaneously. And this falls into that category of usability. And then fourth, I would say every standard, there's going to be a standard for quality control or quality systems and management. So this would be good old ISO 13485. How do you control your DHF? Any change controls or design changes would fall into that. Verification validation efforts for alarms being documented and how to document that, as well as just general requirements for traceability from hardware components to straight alarms. That's going to fall into the ISO document and it needs to be covered in some way, which will vary across different companies and different product lines. So yes, you can always refer to general alarm management standards seen with, let's say, the industrial applications. But these are just some examples of what they look like in medical devices for niche domains like acute renal devices. Back to you.
I need to add couple things and just to explain to everyone why are we going over these standards. But before that, I need to mention that again, it doesn't mean that we are compliant with these standards. I really want to highlight this out. So in the IEC 6061-1-8, it explains that the audible and the visual alarms should be in a certain way. For example, I think as I read through it, it's a mandatory to use colors in the alarms, and this is an example I'm gonna bluntly give here. We do not assist colored light in our Krake, right? Maybe this might be in the future design. I'm not saying we're planning for it, but I'm just giving an example how right now we're not compatible with these standards. But why are we talking about these standards? Um, as as uh as we mentioned before, and when we went through the priorities, the classes, and the types of the alarms, we talked about things that we will help the operator with by bringing them ADaM and Krake. So let's go back to Krake and ADaM, and um, let's see how can Krake and ADaM help bridge the gap between the regulatory bodies and hospitals, which is medical institutes, and so on. I think next slide. Alarm management written by Holyfield and Habibi helped to shape our design. So we just wanted to acknowledge its impact and help with our initial design during scripting our alarm management lifecycle. Next slide, please. Right, buckle up. The alarm management lifecycle, as formalized in ISA and IEC and extensively described by Eddie Habibi, provides a structured framework for designing, implementing, operating, and maintaining alarms that supports timely and appropriate operators' response in practice. However, many organizations struggle to consistently apply and sustain this lifecycle due to fragmented tools and manual workflow, which will be automated by ADaM, and a limited visibility into alarm performance data. This presentation introduces ADaM, Alarm Design and Management, a software platform, together with Krake, a hardware-based alarm annunciator, as a unified system that operationalizes and automates key stages of the alarm management lifecycle. Next slide, please. Effective alarm management is essential for maintaining safety, reliability, and human performance in complex systems. Now I'm going to walk through the 7 steps for a highly effective alarm system as described by Holyfield and Habibi. I split them into 2 categories: the steps you always need and the steps you implement to improve performance over time. Stages 1 through 3 are always needed. Stage 1, develop, adopt, and maintain an alarm philosophy. In our case, we're adopting the alarm philosophy, and we're going to cover that soon in the next slides. Step 2, collect data and benchmark your systems. Step 3, perform bad actor alarm resolution. In our approach, ADaM is the software layer that manages the alarm lifecycle, and Krake is the edge annunciator that enforces the intent at the point of care. Stage 1 is alarm philosophy. This is the policy, the rules of the road. An alarm philosophy is a written standards. So everything we talked about, everything Megan mentioned in the previous slides about priorities and classes and how to respond to alarm is a written standard that defines the behavior of the alarms, which alarms are allowed to exist, how they enunciate, what response is expected, and so on and so forth. So alarm philosophy provides an optimum basis for alarm selection, configuration, and handling methods. In our system, ADaM stores this philosophy as configurable rules and templates. And so Krake enforces that philosophy. How? We're going to get to that, but it enforces that philosophy at the moment the alarm is delivered, right? Practically, this means 3 things. First, Krake can be configured to separate patient alarms from device or system alarms. Second, it prevents the everything is urgent problem. Third, it supports consistent operator prompts. So the user sees what action is expected. So in short, Krake makes alarm priority real in the workflow. Stage 2. Stage 2 is collected data and benchmark your system, and this is exactly an ADaM responsibility. ADaM captures the minimum alarm event schema needed to understand performance. That includes timestamp, source device, alarm ID, or type, and severity or priority, of course. It includes state changes, on and off, plus frequency and duration.
Megan, are you supposed to be on the next slide? Okay.
Continuing with collect and benchmark, sorry.
Right. It includes shelving and muting events, who did it, when, why, and for how long. And it flags standing alarms that last too long and chattering alarms that rapidly toggle on and off. From that, ADaM produces benchmarks, for example, alarm per patient hour, top 10 alarms by count, and top 10 by time and alarm. The percentage of alarms that are actionable versus nuisance based on our classification rules. Krake supports stage 2 by doing reliable logging at the edge. Third stage, which is the bad actor alarm resolution. A bad actor is an alarm that dominates the load, the most frequent, the longest lasting, the most disruptive, or the most likely to fatigue the operator. ADaM generates bad actor reports and recommends configuration changes. That can include time delays, deadbands, correcting priorities, suppression rule where appropriate, and escalation adjustments. And so ADaM's recommendations are based on analyzing the alarm philosophy together with the collected data. After those configuration changes are approved, Krake can implement the approved behavior at the edge. Things like rating limits repeated alarms, improved annunciation, and escalation logic that matches the philosophy. So ADaM enables you to pinpoint your exact problem and apply solution by analyzing alarms and providing recommendation for the configuration changes to improve performance. Let's move to the next slide, please. Now, stages 4 through 7 are the steps we implement to systematically improve alarm system performance. Stage 4, perform alarm documentation and rationalization. 5, implement alarm audit. 6, implement real-time alarm management. 7, control and maintain the improved system. For stage 4, documentation and rationalization, often called DNR, this is where we build a master alarm database for every alarm. Remember when we talked about how we need to look at our most experienced operators and document what they do when certain alarms are triggered? This all go into a database that is called master alarm database. For each alarm, we document its purpose, the likely cause, the consequence if ignored, the correct priority, the operator response, limits and set points, and any time delays. So ADaM provides the DNR workspace. Krake uses that rationalization at runtime by displaying the approved response guidance when the alarm occurs. So the operator sees prompts that matches the rationalized record. Step 5 is audit and enforcement. The goal is to prevent drift because alarm systems decay over time if changes aren't controlled. And this is one of the things that is crucial and regulatory bodies usually check. Krake support this by verifying its local behavior, matching the approved profile, using versioning, configuration hashers, and audit timestamps. Step 6. Well, this is where we manage nuisance in a controlled and safe way without hiding risks. A key concept here is the distinction between alarms and notifications. ADaM governs shelving through policy, permission, time limits, and a full audit trail. Krake is the human-safe interface that makes this usable. Stage 7 is control and maintenance. ADaM can provide dashboards, monthly reviews, packs. Krake reinforces consistent behavior at the point of use. How? By supporting an acknowledgement and act culture, not a mute and forget culture, right? So self-optimizing become real, measure, adjust, and sustain. Next slide, please. ADaM functions as the governance and intelligence layer, supporting alarm philosophy development, alarm identification, rationalization, prioritization, documentation, and manage of change through structured workflow and automation. ADaM promotes consistency, traceability, and alignment with alarm management standards. I would like to invite Robert to tell us briefly about ADaM. However, we will learn a lot more about ADaM during next month's gathering. Robert, over to you.
Thank you. So ADaM stands for Alarm Dialog Management. And what we're trying to do is to do the things that Nagham just said by, for example, keeping logs, but in particular, managing the information that goes to the human operators through the annunciators. And the annunciator is a fancy word for the physical device that makes noise or flashes lights to get somebody's attention. But those are somewhat limited in the information that they can provide. They're not like a full computer screen. And even if they were, in many alarm conditions, you don't have time to read an enormous amount of information. So believe it or not, I think we're actually being very forward-looking here in designing a software system which models the human being's cognitive ability to respond to alarms and manages the priority and the severity of the alarms that are coming in. And so, as Nagham said, what we're going to do is we're going to build an open source system that can be reused by anybody. Now, in order to reuse it, you have to program it, right? It doesn't tell you what the alarms for your particular business or your particular enterprise or your medical condition are. And so on the left side of this diagram, we have domain-specific alarm policies and alarm configurations that are going to be encoded. But once you've configured it and it's up and operating, the fundamental things that happens is you have some alarm conditions, which are usually detected by a sensor. Sometimes it's a human being throwing an alarm, but you have alarm conditions. They're managed by ADaM that sends messages to the annunciators, which get the attention of the operators and collect information back from the operators. So, for example, if an alarm is going off too often, an operator is allowed to shelve the alarm for a limited period of time to say, please don't make that loud noise, which is distracting me for the next 5 minutes because I know what to do. But the operator is sort of not allowed to forget about it because they can't make it go away forever. And all of that is just a management for the purpose of decreasing the number of mistakes that human beings make. And in the end, the purpose of this is to save lives. In some cases, it can be used for something less important, like make a good loaf of bread and don't burn it. But in many cases, what we're talking about here is medical conditions that need to be met. So this is, as engineering problems go, what would be called a hairy problem. It's a problem that has a lot of little things that have to be taken care of. And I think it's actually really ideal for an open source ecosystem or an open source team or multiple or open source teams. And as you can imagine, this complexity creates a tremendous expense for firms that have to do it and people who have to deal with it. And that expense, as Megan pointed out, which is growing, is an opportunity for us as open source software and hardware engineers to really benefit the world by offloading some of that complexity into modular systems that can be reused. Back over to you, Nagham.
Thank you. We're ready to move to the next slide. Yep. Let's talk more about Krake. Krake serves as the physical alarm execution and annunciation layer, just as Robert mentioned. So Krake is equipped with SPI, UART, and Wi-Fi interfaces. And that's how it receives the, I'm going to get a bit more technical here to explain how we get the alarm. So Krake subscribes to a broker, and then the alarm is published to this broker. And this is possible because of the Wi-Fi interface. However, that doesn't mean that Krake cannot be communicating with older equipment that are not Wi-Fi enabled, because it also have the SPI and the UART interface. Krake got onboard audio files, visual indicators, and a local display. It implements the alarm strategies defined in ADaM and present alarms to operator in a real time. And I think we already went through that in detail, so I'm not gonna do that again, unless anyone have any specific questions. I'm ready to answer. By delivering standardized audio, visual, and textual annunciation independent of the primary control system interface, Krake ensures that alarms remain perceptible, prioritized, and actionable under all operating conditions. So I'm ready to move to the next slide. Okay, this slide is mostly to acknowledge Krake team members' work and celebrate it with you. What we're looking at is a collection of efforts, and for example, in the left bottom corner, we see the enlarged enclosure done by our volunteer Courtney. In the upper, so we're gonna also go over the third picture, third from the left upper line. That's an first line. That's also an enclosure design done by Yahya. We've got a picture for the Wi-Fi manager that allow us to easily connect Krake to the Wi-Fi. Okay, the Wi-Fi model is also there to show how and what we're using to save audio files. I think we're ready to meet the team Krake now. Next slide, please. Oh, no, before that. Public Invention support Krake and ADaM team financially to build and test prototypes. So this is an estimation on what we're spending on Krake and ADaM. Next slide, please. Meet the Krake and ADaM team. Most of the team members are with us tonight. I'm just gonna give some time if anyone wants to or would like to say anything, maybe. If not, we're ready to move to the next slide. I'm gonna give 3 seconds and then we can move to the next slide. All right, no. Next slide, please. All right, so can you still hear me? All right. So we're ending up with Krake. This is the legacy design of Krake, and we will soon have the new enclosure presented and added to the website. We're ending this presentation with, can you please move to the next slide? We're ending this presentation
in books and the different sources we used, but
we're gonna go into Q&A session.
Okay, well, thank you very much. So I have a few comments before we begin the questions. That was a long time talking about regulatory stuff, but I don't think people should be afraid of regulation. I have read the FDA laws on these things, and I've studied them a good deal. And basically, what these things say is you just have to document everything. It's really not much more complicated than that, right? Like you have to prove that you've thought about it. You have to produce the documentation, and you have to use, good engineering practices, which include a lot of documentation. Okay, so that part is not not something. It sounds like it's super duper complicated, but it isn't really. Okay. Now, the way I imagine Krake and ADaM being used is that they will be used by other firms. Okay, so Public Invention is technically a firm, but it's a nonprofit firm. We're not trying to make money, and we're not really trying to produce a product except to the extent that it helps somebody else. So in any industrial or medical situation, someone else is going to have to decide and configure the alarms. And that's what Hollyfield and Habibi mentioned, and Nagham pointed it out. That's called the master alarm database, which is perhaps not the best word. It should probably be called the master alarm documentation, right? Because that's really what it is. Okay. And this is not different than what other open source software teams have done, right? We're making a piece of software and hardware, which has no value on its own until someone else takes it and utilizes it for some purpose. Okay. Now, if you're listening to this on YouTube after the fact, I want to point out that we could use more volunteers. There's always more work to be done in terms of hardware design, software design, and things like user interface design and marketing, fundraising, those kinds of things. I could be wrong, but I believe in our identification of ADaM and separating it from the annunciators and so forth. And some of the things that we're trying to do with ADaM, we're actually at the kind of the frontier of research that's being done in alarm management. And so I think this is a really good project for open source people to get involved in, because it is a way to save lives, and it's complicated enough that there's a lot of really interesting work to do, but it doesn't require an enormous expense in terms of equipment for people to do good work. Okay. On top of that, if you were a university researcher, having ADaM and a set of Crakes would let you perform all kinds of psychology experiments. If you wanted to research alarm fatigue, if you wanted to research how well people respond to alarms, how to best organize alarms, we're making a framework or a test bed in which those things could really be studied very effectively. And that's one of the things that I really hope is done with this project. And now I hope either Megan or Nagham will comment on that, or other people have questions.
Yes, I'm going to take us back to the donate page for the project, just so that we can kind of talk about needs and things related to that project. Feel free to scan the QR code if you're interested in donating to them or learning more through our website about what Krake has to offer. And just ask us questions, come off mic if you feel interested, like, hey, what demand are they looking for maybe into Q2 or Q3 of this year? I'm sure that because a lot of them are attending live right now, that you can kind of get some insight on what the needs look like for the coming months. Nagham and others, let me know if there are specific skill sets you're looking for on your team or could utilize in the coming months.
I'm glad you put this slide up, because one of the things that someone listening to this talk might not understand, they might think that this is all kind of planned. It's not planned. The Krake exists and can be demoed, and you can use it, to send messages from the United States to Lebanon, and the Krake will make noises there. It's a functioning alarm system. They're currently making a new version that has a rotary encoder and a larger speaker, so that the speaker can produce loud messages in the human voice, in recorded voices. And that'll be a major feature forward, which the previous version didn't have, which will make this really good. The ADaM software is only just beginning. Cyturon has done some really interesting work, which is in our GitHub repo, including some simulations. But I'm confident that the combination of Alarm Dialog Management with an open source reprogrammable annunciator like the Krake will eventually be very valuable to a lot of open source teams or firms that are trying to save money by offloading some of the alarm design onto an open source system.
I feel like I need to point out that one more time. The use case here for Krake is medical devices and medical systems, but Krake is a general purpose alarm that can be used in the industry field or just at your home.
Thank you. That's right. Let me. So I'm
And
hoping.
in fact, right now we're using it as an annunciator that we alarm one another if we need to do something urgently. So we try to test it in this way. So it's really go from super general, but the use case for tonight was in the medical devices.
So let me speak to that just a little bit, and how I came up with this design. Although some people here, Lee Erickson and Lawrence, who's in the meeting here, wrote a paper that's available in Hardware X describing an early version of the Krake. It's called the General Purpose Alarm Device. And so you guys can look that up if you want. It's also, of course, an open source project. Public Invention did not invent, but it supported the Polyvent pandemic ventilator, which remains the easiest to build completely open source human ventilator in the world. It's never been used on a human being. We didn't need it there. but it's a good ventilator in some ways. Now, a medical device as complicated as a ventilator, which is life critical when someone is being mechanically ventilated, the machine is responsible for keeping them alive. It is absolutely necessary to have such a complicated life critical machine have alarms. Okay. The one exception to that is there usually are not alarms on what are called transport ventilators, which is when someone is in an ambulance being transported from a first aid situation to a hospital. Those ventilators often don't have alarms. Okay. But a hospital-based, ICU-based ventilator always has alarms. Now, uh, if you just apply the basic open source philosophy, which is sometimes called the Unix way, which is from 1970s, um, the idea that makes sense from an open source point of view is to not always reinvent the wheel. Let's create an open source annunciator that can be reused for a number of purposes. Let's create an open source piece of software for alarm dialog management that can be reused for a number of purposes, and try to offload the difficulty of adding that, for example, to the polyvent. So I don't know for sure if we're going to keep making the polyvent, if the polyvent is ever going to be used. But if it's going to be, you grow into a device which is made by a firm, which probably won't be public invention, and sold as a medical device which is used to keep human beings alive, it has to have an alarm system. We're building an alarm system, but of course, we're also making it so it can be used on other devices. And Victoria has corrected me that transport vents have alarms. I'm sure in the pandemic, some of them didn't, but yes, maybe that's true.
So feel free to come off mic if you guys have any additive comments, any questions, or if you want to know more about the Krake or ADaM project. We'll give it a few more minutes.
I apologize for coming in really late. Is this working towards publication, or has it already been published?
Great question. I feel that they're working on a publication, correct?
Naram, do you want
We're working on a Hardware X article.
Wonderful. Fantastic.
let me add that an earlier version called the GPAD has already been published as a Hardware X article, but the Krake adds so many features to that, which is wireless operation and audio and a rotary encoder, that we're going to publish another one. We've just now started writing that. They're making the thing there. We haven't really started the ADaM publication. Citron and I technically have started a publication, but that project is still very immature. But I hope that will be published as well. But you know, a lot of times public invention does stuff and we write a technical paper. And in this case, I really hope we get people to use it more through like demonstration than through technical papers, because we have to do more than just write a paper in order to get people to use this. So, you know, what we're going to do is not produce it the way you would produce a product, you know, but make them and do alarms and do testing and stuff in a way that we can produce really compelling demos of how this adds to the state of the art.
And I'm gonna take this chance to mention that while researching alarm management and alarm management lifecycle, the gap was so obvious. And ADaM and Krake bridges that gap in a way that when most of the things are still done manually, it can be automated with ADaM. And by automating things, we guarantee maintaining of change, which is crucial to not only reach the best system, but also to sustain it.
So, for example, if you have, as Naram pointed out, if you have a functioning alarm system, you really need to do audits and tracking and statistical analysis of what alarms have happened in the past, how quickly they were responded to, and how effectively they were responded to. Well, you really need some kind of an alarm management system to handle that for you and make that an easy process. Auditing those alarms is going to be almost the same no matter what the alarms are. So, for example, the alarms themselves, what Hollyfield and Habibi call the master alarm database, is going to be completely different for every user of an alarm management system. But the auditing system is going to be almost the same for everybody.
Adding to that, it might be easy to experienced operator to know how to deal and what to do when an alarm goes off. But it's not the same situation for a fresher, right? Most of the time, they're not going to know what to do until they know what to do. But here, Craig comes and giving the suggestion of what should be done when this alarm occurs.
So one thing we can think of that we haven't touched upon is making the alarm management system really intelligent. Okay, and nowadays people would say artificially intelligent. I kind of don't like that idea, but let's imagine that we had an artificially intelligent thing. I like to think of like a little super brain in a box in the alarm management system. Well, it could do something quite radical, like it could detect that the operator is not an expert. And on the basis of detecting that, it could change the messages that it gives. Okay, so for example, sadly, sometimes people who are not trained have to give first aid, right? Someone is drowned, someone is bleeding, someone is burned. You have to give first aid to them. It would be better if we always had trained medical professionals to do that, but that's what we call first aid, right? There may be situations where this occurs, and the Krake could change the way it behaves based on detecting that the person is a highly skilled medical professional, or that they're just some person who happened to be there when someone had a heart attack or was injured.
I mean, I would even add, I think the hardest part to get that to realization would be really the, I guess, regulation for the artificial intelligence attribute that you would add on to general alarms as well as like alarm management systems. So like I'm not very well versed when it comes to encryption, security, or of patient information at that regard, but also of how you would control algorithms like that. Like what regulatory standards are necessary there, especially at the medical device, a highly constrained and regulated environment. I'm not sure if that even exists just yet in documentation as a guidance even.
Right. Now, the way I view these projects is they're not going to undertake that regulatory burden, because that regulatory burden always falls on whoever is actually managing the alarms. Okay. But what we want to do is make it as easy as possible for them, right? We want to remove the parts of that which are not specific to the work that they're doing.
Yes, exactly. And that's there's things that ADaM does that takes the weight off the off hospitals, let's say. So in documentation of what okay, so in the philosophy of the alarm that is stored in ADaM, we've got what would you do when a certain alarm goes off, right? But then what is actually done is also documented. And then it does the comparison for you about what should and how we should we deal with an alarm versus what was actually done, right? And then it gives you that report that you can use and analyze. And it can go further than that by analyzing this report and giving you suggestions to edit the configuration. And that would be a result of enhancing your alarm. What does this mean? When you're so when we mentioned the bad actor report, when you hear that or when you read that, you'll notice as if you've caught the bad guy, right? The alarm that occurred, more than 50%, like the percentage of it is like 50% of the total alarms. You need to look at that. Like it narrows it down for you to look at one alarm and then maybe there's a set point that needs to be changed.
Right.
So so the result of all of what we're trying to say is that the flooding of the alarm is not there anymore. A more peaceful environment, people can really focus on priority and not like false alarms going most of the time. Robert?
That's right. And, as I said before, alarm fatigue research is something that this really enables, I think. Okay. I'd love to hear people from the audience, but let me just say one additional thing. Why are Krake and ADaM separate projects? Because we want people to be able to use a Krake even if they don't want to use ADaM, and we want people to be able to use ADaM even if they don't want to use a Krake. It's just that simple. The two go together, but it's also the case that you should be able to use one and not the other. And that is not necessarily our philosophy. That's just the basic open source engineering philosophy, is to make things into components that can be composed together to make a more powerful system. Okay, if we don't have any questions soon, we're going to have to wrap this up. Does anyone in the audience have any questions?
Oh, I have a question.
Oh, it's also a first question, apparently, but okay, go, Joe. Go ahead, Joe.
What has been done to experiment with the effectiveness of ADaM at reducing fatigue, and like how have you had it trials runs, or how is it all hypothetical so far, or how have you approached it if you've gotten a chance to do testing?
So as mentioned earlier, this use case, medical and hypothetical. And in fact, to do the testings, we can't do it ourselves. So we need to have more inventory and put it out there and actually test it. And right now we're still in the design stage.
Well, let me amend that. That's true for the Krake. Now, Cyteron, who is here, has done some very powerful programming to make test situations, some of which we showed at the June situation. But let me show you the bottom thing here. What this is a Monte Carlo simulation. When I hit this button, it just performed 200 trials of different policies and human strategies which are to be used. The policy is what the machine does, and a strategy is a simulation of what a human would do. So what we've done here is we're measuring harm in terms of how long an alarm condition exists which is not responded to. And in some circumstances, we can see that there's quite a large difference in the amount of harm based on the policy that the machine implements. Okay. And Cyteron did all of that. Okay. Now, you've also done this, and this is going to be loud. So y'all be prepared. I'm going to do something now that will seem weird. Cyteron made a game that a human being can play, which is a way to measure alarm fatigue and performance. Okay, so I'm going to do it right now. This is a live demo.
Can you describe what you're doing while you go?
No, because it's too hard. But now it's over, and I can describe it. So what happened is, at randomly, alarm conditions were popped up that had a written action. And what I had to do is I had to read it and go over here and hit the correct action as fast as I could. Okay, and you heard it. It was really annoying, and it's almost frightening, to do it. Okay, now that was like I guess 8 alarm conditions. I was responding to them as fast as I could. You might not have been able to see that. And this
There were no
Or
audio
hear
on
that.
this side. Yeah.
You
Yeah.
guys didn't get the audio? Oh,
No.
okay. Well, trust me, it's really loud and scary. Okay. And each alarm condition produces a different noise, and it is distracting the way an ICU can be distracting when there's a serious problem, and nurses and doctors are trying to think while all these alarms are screaming at them at the same time. And that is part of what is called alarm fatigue. Now, this is not a good alarm system. This is a test bed for alarm systems, right? This is a mechanism for testing that. And of course, this is pure software. Cyteron did this as a GitHub pages. Any of you can go to this URL. I'll copy it right now and play the game yourself. I'll put it here in the chat if you want, and just try to do it or do the simulation. You don't have to have a login or anything. It's just GitHub.
One
page.
question I have for Cyteron is there a database aggregating the results of different users to see user data? Like on average, most unclinically trained users respond at this rate. And then maybe you can get a survey of just clinical trained personnel. I mean, this isn't, specific to a specific treatment, but you could technically see like if their response time is faster. So like if nurses are faster and more accurate than the average human, I wouldn't be surprised at that trend, but I would like to see that comparably for this game. That would be interesting as well.
Cyteron, are you there? Can you unmute and answer that? If
Yeah,
not,
I didn't get the question. Can you repeat the question, Megan?
Yes. So essentially what I was asking is, are you collecting the data from each run as people play the game? So if as different users log in from different IP addresses and are playing that game, are you storing any of that data by any chance, or is it just
No,
lost?
Megan. I think this game is played by me and Rob. That's it. Yeah, I don't know whether anyone is played or not. It's just like a prototype.
Gotcha. Do you think
Yeah.
that there are ways to add in store databases to track, like almost like a survey poll, right? So when someone submits that poll with their URL, it stores it in a database. That'd be really interesting because then you can gather user data by leaving QR codes to this game like Pokemon Go, but seeing how
Yeah,
much it varies.
that's really a good approach. But right now we are working on a different thing. This is just like a prototype for us. So right now, me, Rob, and Muhammad working on the other type. We are working on like getting the Krake simulator with us, like acting as a Krake simulator and sending alarms and acknowledgements too. So right now, like we are not doing anything about this one of collecting data or like getting feedbacks on this. I mean that would be a great approach, but we should like stop the process and like focus on this one again.
Gotcha. Thank you.
Yeah.
Um,
That was actually going to be my follow-up on that, was having tracking the data of that would be presumably like the most interesting part of it, because then you could see um, how it actually tracks, and if you could see like somebody who has done it 10 times, do they get better? Do they get more fatigued? Do they get worse? You know, things like that.
Right. Well, okay. So let me point out, I didn't ask Citron to do that. He is recording exactly the time and every action, including the mistakes that are happening, but we're not associated those with a login or database or anything like that.
So he
But
is
there's,
recording and he is saving it, or just he's
yeah,
recording it and then deleting it?
well, the latter. He's recording it and then deleting it because there's nowhere to save it. But we could just add like a download button here for it. So I would probably change this page if what Megan suggested it becomes valuable. I would change this page so that the results of a human experiment could be downloaded and saved, as a CSV file for analysis outside of this framework, rather than try to build like a login system where we keep your data yourself, right?
Yeah, I wouldn't think that you would want to log in either. That
Yeah.
doesn't sound attractive at all. But just your anonymous login would track a few things like the IP address to try and identify you as being unique, at least, maybe slightly. And
Or
maybe what
a
region you're
browser
from.
cookie. A
Or,
browser cookie could do that.
maybe. But basically, rather than saying, oh, I finished my test, let me download it, right? It's more like everyone who runs and plays it, we save some information, and maybe, like Megan said, there's a survey that's as simple as a checkbox of, do you work in the medical profession? And just like very minor, very low overhead that you don't want people to have to create a sign in or, whatever. Because that, I don't think that really contributes anything. But then you could, if instead of a download, it just goes to a backend database, then anyone who comes and plays it anytime gets stored off to where you as the administrator can go see all of them versus the user hitting a download button.
Well, yeah, so here's the truth, and it's kind of a hard truth. That's a really good idea. You could enter it as an issue on this site, and maybe Citron will enter it there. The thing is, you're the first person, and Megan are the first person who's acted like they really wanted to use this. And so I sometimes go where the energy is. If no one is acting like they want to use it, I don't think of adding any features. But, if any serious researcher says, oh, I want to use Citron's code to do something serious, we would stand on our head to make it easy for them to use it. And then take whatever we learn and put it into ADaM as well.
Definitely. Well, just are you marketing it? Because I think if you don't market it to the masses, you're not going to really know what appeal it has because it's sitting quietly in a hidden, tucked away like browser, right? Like some URL nobody has access to.
Well, no, I mean, this is public URL. It's in our GitHub repo. It's not.
They have access, but they're not aware of it.
Yeah,
Exactly.
but
Exactly.
are we marketing it? No, but I mean, there are only so many hours in a day, right? I mean, we're spending our time building it. If some volunteer listening to this on YouTube wants to market this, that'd be great. We would love help doing that, and it would be a good experience for someone who wanted to get experience marketing something nerdy, technical, and medical, which it is.
We are over time, I just noticed. So if anyone needs to drop off, we understand. We'll probably end the recording soon and then just stay for kind of just like follow-up questions, comments, stuff of that nature.
Well, I'd like to take this time to say that next month, February of 2026, is going to be our volunteer appreciation night. And so I'm going to invite personally all of the volunteers, some of whom will be getting awards, to receive their awards and be honored. And we're going to do a short summary of all of the 10 projects that Public Invention is working on. So it should be a very interesting time. We're going to have a guest speaker named Gloria Clark, who was one of the first volunteers during the pandemic for Public Invention, and she is a professional artist. And I think she's either a teacher or a professor of art as well. So please try to join us the third Thursday, which I think is the 19th of February next month for this. And that being said, I'm going to end the recording if that's okay with you, Megan, if you don't have anything further to say. Nagham, do you have any closing words?
Thank you all for being part of Krake and ADaM team. We really are grateful for all the efforts that is being put into these projects.
Okay, thank you. Signing off.